And I just want to see, is everybody here ready to hear about data mesh? I think we can be a little bit louder though, right? Like, are you guys here to hear data mesh? Woo! Woo! All right. All right, one more time. When I say data, you guys say mesh, okay? Data. Mesh. Data. Mesh. All right, one more time. When I say lake, you say house. Lake. House. Lake. House. This is the best crowd of the day. Yes, sir. All right. Thank you so much for joining us. My name is Jason Pohl. I'm a director of data management here at Databricks. And I'm joined on the stage with Sam, who's one of our experienced solution architects, came here direct from London. And we're going to talk about meshing about with Databricks. So essentially, today's agenda is going to be why the data mesh. You might have heard Zhamak Dehghani talk about data mesh today earlier at a fireside chat. I'm going to explain a little bit about what we hear from our customers and why they think it's important. Then I'm going to talk a little bit about data lakehouse and why we think that's important and how you can do the data mesh on a data lakehouse. And then we're going to basically talk about an example from one of our customers that Sam's been working with us, which is a top 10 pharmaceutical. So
Jason,
yeah,
tell us why organizations should do this.
Okay, well, why the data mesh? So the data mesh, fundamentally, it's about decentralizing the distribution of responsibility and creating these autonomous teams that are close to the data. And it's got 4 main pillars that Zhamak has come up with. So the first one is about domain ownership. So if you don't have it's not about having a centralized team or a centralized place to do all of your data engineering. It's about decentralizing that into different teams that are called domains. And these domains are autonomous, they have the ability to make their own decisions, and they have the responsibility for having the data closest to them. And you can do it in a couple different ways, and we'll go into that in the next slide, but essentially they're mapped close to the business org. The second pillar is data as a product. So you want to treat your data as a product, and what that means is a product has an owner who manages it and treats it as such. And you also have customers, so your consumers would be customers, and you want to make sure that you're serving them well, so you want to measure if your product is actually being impactful or not. And you do that with various metrics, including the most rudimentary one is an NPS score. Finally, you need a self-serve platform. So you've got these autonomous teams, they're charged with creating data products and owning them, and they need their own infrastructure to be able to do it. And you can't have every separate domain team having to manage their own infrastructure, otherwise it won't scale. And finally, federated governance. So just like every team is distributed the responsibility to be able to create these products and own them, you need to be able to distribute the governance around this as well. And you need a decentralized form of doing it, and you need a way to basically have self-serve platform that can offer a governance layer with it. So domain data teams, this is how do you organize your organization to do a data mesh. And I would say a data mesh is probably about 80% people, process, and organization, and 20% technology. So fundamentally, you have to figure out where are these different domains. And you can split them up in a couple different ways. So you have some domains that are aligned with the source, right? So if you've got a CRM system, you might have a domain that's just focused on CRM data. And that way, your data practitioners can sit alongside the people who are generating the data and then have really good domain ownership and domain knowledge they can share between them. You might have domains aligned with consumption. So maybe people who are aligned with consuming that data, and you want to have a team around that. And then finally, you've got other ones like, we've got a recommendation graph here, but these are like shared domains. So I think about in traditional data warehousing, you might have certain entities that you're conforming together, like customers or products, and you're taking in data from lots of different source systems. Those might be a shared domain that you create. And fundamentally, these teams are going to have to get funded from somewhere. They're going to have their own budget, but they get to prioritize what's most important for them and serving their customers.
So that's good.
Yeah.
Mighty introduction. So how does this fit in with our destination lakehouse?
Oh, it's a good question, Sam. So why would you actually want a data lakehouse? Now, you probably saw some of these slides from Ali's keynote earlier, so I'm not going to spend too much time on them. But with this data maturity curve, every organization in the world is somewhere on this curve. And the top 1% of the Fortune 500, the FANG companies, they're in the upper right. So they've already gone past, the hindsight, which is the lower left. So the orange boxes are all about doing analytics on your historical data to tell you what's already happened. Whereas the navy blue boxes, or the navy blue circles, they're all about advanced analytics. So trying to predict what's gonna happen, trying to come up with a recommendation, a list of recommendations on what to do, and then finally, sometimes actually taking or automatically choosing one of those recommendations. And so historically, these two different sets of problems have been served by two different silos, or data stacks. You've got data warehouses that have been used for decades to do the historical backward-looking analysis, and you've got data lakes that were used for doing the machine learning or the predictive analytics. And this is because whenever you're generating machine learning models, typically you need to do that at the most granular level of data, because you need to be able to see the data as it's coming in so that whenever you go to infer a prediction later on, you've already got that granular data. And you also are increasingly doing machine learning on unstructured data, so data that doesn't fit into tables. So these are images, audio files, videos, et cetera. And so a data lakehouse has kind of like formed because we believe that having these two separate data silos or data stacks, it's not good. It's not great for the business. It's a duplication of data, duplication of effort in teams. Fundamentally, everybody wants to have their data in one place and do all their use cases on it. So we've come up with these three different tenets for the data lakehouse. One is all of your use cases. So write your data once and then use it for data warehousing, data engineering, data science, machine learning, and even streaming. We want to be able to do it across all of your data, so not just the structured data that you fit in a table, but also with unstructured data and even semi-structured. So being able to do this on images and videos, et cetera. And finally, you want to make sure that you're using open standards. A lot of the problems with data warehouses that they've been built up over the years with these proprietary interfaces. And whenever you want to get off the data warehouse, it becomes a huge migration effort. But with the Lakehouse, because we're building every layer of the stack with open technologies, it allows you to kind of bring your own open source libraries if you're doing machine learning, or be able to fit into a data mesh so that your common layers that you're interfacing with gives you interoperability. All right, so that brings us to the Databricks Lakehouse platform, which we talked about earlier today, but we believe in like three key tenets: simple, open, and multi-cloud. Simple in the sense that you can do all these different use cases on one platform by writing your data once and doing it many times without having to have these separate data stacks. It's open in the sense that it's using open source technology, and you can basically use the data that you've saved in a Delta Lake and then use that with multiple engines. So there's already several open source engines out there like Spark and Presto that can work with Delta Lake. And it's multi-cloud. So you can basically have one set of APIs that exist across all major cloud providers and use that to your benefit.
All right, data mesh architecture with Databricks.
All right, well.
Getting into the details now.
Yeah, so we talked about data mesh, we talked about the Lakehouse and Databricks, but how does it actually work? So we talked about data as a product. So if you haven't read Zhamak Dehghani's blog post on the data mesh and what it is, I highly recommend you to do it. And this is taken straight out of there. So these are 6 key tenets of what it means to have data as a product. And it has to be discoverable in the sense that whenever I want to go search for something, I should be able to easily search to see if something exists in my organization or not. And if it does, then I can go to it and then find it from a URL link. And that's what addressable means. So being able to actually access this thing and have it be interoperable, so that because we're using open standards, one domain might be using one technology stack and another domain might be using another technology stack. But as long as you're using these open standards that are interoperable, each domain can consume these other domains' assets. It has to be trustworthy in the sense that, we talked about how every data as a product has metrics. So you need to be able to have metrics around, is this data clean? Is it accurate? Is it fresh? So you have these different metrics that you put along your data products. Self-describing, so can I easily, find this in a catalog and find out what is the schema of this data? What is the description of it? And then where did this data come from? What's the lineage behind it? And where is it being used? So where is it going? And finally, secure, just being able to trust that the data assets you're looking at, are maintained in a secure way using enterprise standards like integrating with your identity provider. Now, whenever people think of data as a product, they immediately think of like tables of data or views of data, which is probably the #1 data product. But there's all these other data products as well. So you might have raw files if you're sharing video files. It could be a stream or the output of doing analysis in either a dashboard or a notebook. And finally, machine learning models or features that you might create that get shared across the enterprise. And all of these different data products that kind of fit, I put it into a hexagon here, but you can think of this hexagon as a workspace in the sense that a Databricks Workspace, it's ingesting data, polyglot data sets from the cloud or otherwise. You've got a collaborative data domain team that's interfacing with this and building data products that they then share with consumers. And this workspace, it could be permanent, so you could set it up so it's always with your team, or it could be ephemeral, where you spin up a workspace for a project and then you tear it down after that project is over with. And these different workspaces, they could be on different clouds and different regions. There's no limit to the number of workspaces you can have because you've got a number of different teams. And as you can see at the bottom, you've got this common self-serve infrastructure layer with all the common utilities you would expect every data domain team to need, but this way they don't have to manage it themselves. So, common identity across the enterprise, an audit trail to see who asked for access to what and who got granted access, a catalog that allows you to do discovery and see the lineage of all these different data sets. And then finally, cost control, making sure that you can set budgets so that a team can operate autonomously, and if they get close to these thresholds, they get alerted. And if you want to use data or data products in between these different workspaces, we've got delta sharing. So delta sharing allows you to share data and eventually ML models and everything else between the workspaces and across clouds and across regions. And you don't have to worry about sharing it just within your enterprise. Some of you will need to share these data assets with external partners, suppliers, customers outside of your enterprise that aren't on your same identity platform. So delta sharing has been built, and we announced it last year, but it's a first open standard for doing data sharing like this, and it's a way to securely share assets within your organization with people that are outside of it. And as long as they're using one of these supported delta sharing clients, which we've got for open source platforms like Pandas and Spark, or it's already built into a few commercial products like Power BI and Tableau as well. So that's just a generalization of how we've been doing data mesh on Databricks. But now I'm going to turn over to Sam, who's worked with one of our largest pharmaceutical companies, and he's going to tell us about how they've been doing data mesh and some of the lessons they've learned.
Thank you. So we've talked about how we would approach data mesh implementation on Databricks. There are 6 key tenets that we want to focus on when it comes to governing a mesh architecture. First up, plan for chargebacks, because you've got different business units, mostly in highly regulated industries and large enterprises. You will see a lot of federated autonomy, which means BUs will have a lot of autonomy over the tool choices, the technology, and how they want to go about doing things. So chargebacks and transparency of consumption is very, very important for all of them. Second, plan for multi-cloud at the outset, because 80% of Databricks customers are on more than one cloud, which means it is very, very important to give them a consistent end-user experience, whether they're on Azure, AWS, or GCP, and who better to do it with than Databricks?
Nobody better.
And third is automation is your friend. So like Jason was mentioning, if it's going to be an industry of folks trying to keep up with all the infrastructure changes of spinning up workspaces and tearing them down by projects, it's going to be a challenge. So if you are into Terraform or scripts or ARM templates, whatever that rocks your boat, use them. 4, as you start looking at different BUs within your organization and onboard use cases, you would start realizing that there are varying levels of maturity between your BUs, which means it's important to understand them, ascertain what is required for them to be onboarded onto the data mesh architecture. 5, if life experiences have taught us anything, leaving data repositories unchecked, it will end up becoming a swamp, right? So invest in enterprise data governance practices, processes, and tools, which will help you to weather the storm. Not that you will solve it on day one, but having those as the foundation blocks of your data mesh architecture is pivotal. And finally, like I think Jason was alluding to it, that data mesh is not a technology concept. It also comprises of organizational changes. You might require different skill sets to be onboarded as well for you to be successful on the mesh architecture. So never underestimate that. We'll quickly jump into 5 salient features when it comes to data mesh deployments. So typically in a data mesh, you will have a core node which might house certain centralized services. It could be auditing, IAM, identity management, and access controls. It could be observability, it could be monitoring, it could be cost control. It could be a lot of those factors or processes which cuts across different BUs or data domains. So invest in those tools wisely because it's important for us to get that right at the outset so that your chargebacks, your entire management of your mesh ecosystem is easier. Second, you need to have a solid data cataloging service up and running for your centralized mesh because it's important for data domains to collaborate, easily search and discover data products, and eventually start collaborating at a level where they're able to start looking at creating composite data products that spans different data domains. So it's very, very important to have that central data cataloging solution. House BUs or BU nodes in their own subscription, which means in this customer that I'm working with, they've got separate subscriptions on Azure, and they also have Databricks Workspaces and Data Lake stores, which helps them to be self-sustained, and they don't have to rely on the platform team or a central team for them to manage their day-to-day operations. So that's very important as well. Outline a robust target operating model because, like I said, technology is the easiest problem to solve in this entire cog. You will still have to figure out, how do I operate this? How do I interact with different BUs operating in different styles and fashions and bring them together in a cohesive manner to push the enterprise forward for innovation and whatnot. So when I say operating model, that deserves a talk on its own. But if I were to just pick up those 3 or 4 aspects, it could be splitting them into platform and data ops, give domain ops to the individual data domains, and also you need the data product teams, which will be creating those data products. Create all of those aspects and figure out the interactivity amongst those teams. Last but not the least, have well-defined set of responsibilities, because unless all the actors in the mesh architecture know what they're doing, pretty quickly it'll start descending into chaos. So if you want to avoid chaos, you have to start defining well-defined R&Rs.
And I noticed there's a few like Azure-related non-Databricks services in those nodes. So would you say like Delta Lake helps them, have these other services come in there for the data mesh?
Yeah, so Delta Lake is something that this customer has embraced in their ecosystem at a much earlier stage. So their bronze, silver layers are all in Delta. So they do have other Azure services as well in different ecosystems. So Synapse is one of the services that they use as well alongside Databricks. So it's important to understand that, like I said, different BUs, different maturity, different technology preponderance of using different technologies, which means you won't have the harmoniousness that you would want, as in use just one technology across all BUs. It may not happen ever, but it's quite possible that you would still see the heterogeneity of having different technologies in different BUs. And yeah, this is the road ahead. If there are KPIs, we track 4 of them. There are many others, but I've just highlighted just 4 in the sense how many BUs are getting onboarded, number of users. We have onboarded thousands of users onto the platform. 2 petabytes of data, which is quite big for the organization, and plenty more coming our way as well. We have onboarded more than 300 use cases. The use case adoption has slowed down a little bit, probably because, like I said, if you hit those roadblocks with respect to your BUs, you are likely to start seeing some of the adoption challenges because the cultural aspect of the data mesh architecture is probably something that kind of goes away on the wayside, but that's what triggers such adoption challenges in large organizations. So finally, if we were to start looking at onboarding new services, because data mesh is an evolution, right? You have to start looking at it from the outset. What are the services that we need, and therefore, what are the consumer demands that's triggering those service requirements are very, very important. So if there are two services that we are presently onboarding this customer with, it is Unity Catalog, our governance solution for the Lakehouse, and Delta Sharing, which we kind of referenced earlier as well, because the autonomy of the BUs, the seamless sharing capability between Databricks workspaces, because there are different BUs which are also exploring GCP, for instance, which means multi-cloud is a reality for this customer. So giving that consistent look and feel and usability of a platform can only happen if they all embrace Databricks, right? Databricks on Azure, Databricks on GCP. There is no porting of code. There is no migration. There is no switching on, switching off. Parallel runs, nothing. You switch on something on GCP, you switch off something on Azure, job done, right? So that's the evolution, that's the journey that we are moving towards with this customer. So in terms of the demo, what we want to showcase is our data explorer. So in this case, let's say I'm a data analyst working in the clinical development space. I've picked up clinical development because that's something that I can easily relate to. So in this case, I'm looking at real-world evidence data. So real-world evidence is nothing but, in terms of pharmacological studies, real-world evidence is the impact of certain habits and socioeconomic factors on your patients, which will in turn impact the way you develop vaccines, drugs, and whatnot. So that's real-world evidence. So in this case, let's say I'm an analyst working in that space. I can come in and start looking at the Data Explorer. It is within the Databricks Workspace. So this is a single pane of glass, which gives me all the securable objects in one space that I'm entitled to see. So if I'm seeing all the catalogs and schemas and tables, it means I have entitlements on those objects. So I can traverse through some of these to figure out what I need to work on, or I can also start putting together or searching for things. So it's search and discover, which is one of the cornerstones of the mesh architecture. So I'm searching for something, and I'm saying, okay, I found what I'm looking for. I'm looking for immunization statistics. It's just a table or a data product that I've created. So here, for your schema traversal, you really don't need to have an endpoint up and running, which is quite different to what you're used to. So that's the power of Unity Catalog, because Unity Catalog works exclusively with REST APIs, which means you really don't have to have an endpoint up and running. So I can traverse metadata. I can traverse lineage. So if, let's say, I want to start looking at the entire DAG of how this particular table was populated, then this comes in very handy for certain cases. Like, for instance, let's say there is a BAU change, and you want to understand the impact of that BAU change. Or simply you'd like to start looking at different blocks in rectangles, lineage comes in very handy. So this is the table level lineage, right? So it's very useful. What happens if I want to start looking at column level lineage as well? So if I look at a specific column, in this case, the total cost is a function of immunization cost and the medication cost. So column level lineage is also possible with Unity Catalog. And there are other lineage aspects like entity lineage. For instance, this is the notebook that's populating this particular table. And there is also a dashboard, which is a data derivative that I've created as a result of this table, which is utilizing that particular table. So I'm just flashing a dashboard because what is important to understand is I can do all of this within the Databricks Workspace. I've not really gone outside of the ecosystem. I'm not relying on another BI tool to really perform fine-grained analysis on granular data on your Lakehouse. So I've created all of this, and let's say if I want to share it with my colleague, it's very easy. All I have to do is search for somebody and give them the access, and job done. So if I add them, so they'll have the capability to collaborate and start looking at this dashboard themselves as well. So all of this is fine. It is all within my ecosystem. I'm in clinical development, so I've done all of this. So now comes a requirement where Jason is in vaccines, and he's saying, well, you've done all of this in silos, and I really want to have the capability to start looking at your data because my vaccines development is underpinned by the studies and evidence that I've created as part of my analysis. So that's where Databricks to Databricks sharing comes in very handy. So in this case, with Databricks to Databricks sharing, all I need is 4 SQL statements. Yeah, it's exceptionally powerful because I'm not looking at a massive notebook with hundreds of lines of Python code, which I quite frankly don't get. I don't really have to go into bits of understanding how do I set all of this up. There is a UI as well, which you would have seen in one of the other talks. But I'm a SQL nerd. I love SQL. So all I'm doing is just 4 statements. I'm able to create a share which Jason can consume. So Jason, why don't you come and have a look at how you want to consume it?
Yeah. So I can see, so Sam's, in Sam's domain, he's an Azure person. So he's been running all this stuff in Azure. So I'm going to flip over, because I live in AWS. So I'm going to flip over now to my AWS world. You probably missed it, but like, Azure says Microsoft Azure up here. And then when you're in AWS, it just disappears. So now I'm in my world. I'm in my Databricks SQL workspace that I've logged into. And what I'm going to do is I'm going to open up a query that I had already created. So this is the share that Sam shared with me. So first of all, let me just, I'm going to show all the providers. Make sure my endpoint is up.
We want to run the starter endpoint.
Oh, there we go.
Endpoint is up, yeah.
Switch endpoints here. All right. So I can see that there's actually quite a number of shares that have been shared with me. I noticed that this one, the DAS demo, is the one that you recently created for me. So this is a provider, a Delta sharing provider. So Sam's organization or his domain would have been a provider that shared with me. And I can see in here, there's one catalog, or the one table called patient stats. So what I can do using Databricks to Databricks sharing is I can create a whole catalog, and I'm going to call it RWE patient stats, real world evidence. And I'm going to using this share from this provider in this patient stats table. So by running this, I think we've already created it, so it'll probably give me an error that it's already created. Yeah, it already exists. So I'll just show you what it looks like. So in that table, or in that brand new catalog we've created, I've got a table called raw patient stats. What it's doing is it's using Delta sharing to basically traverse from my AWS workspace to the storage that's underpinning this data, which is in ADLS in Azure, right? And then it's rematerializing that back. All right, there we go. So now I've basically just effectively shared data across organizations, across workspaces. I didn't have to copy the data. I was able to access it in place. And this is useful if I'm doing SQL analysis, but I might actually want to do some more advanced analysis. So if I switched over to my data science and engineering part of Databricks, I can go into a notebook I've created. And the nice part about notebooks is that you can basically explore your data and using lots of different languages. Here I'm going to basically query the same Delta sharing catalog that was created to see this data. And then what else I can do is I can switch from, this is a SQL notebook, but I can just as easily write Python as well. Let's see.
Show result.
I wonder why it's hidden. There we go. And so here I'm doing some Python. I just do %Python. I write some Python. And then I'm basically taking this data. I'm doing a little bit of an aggregation. And I'm displaying that. Let's see. All right. And then here I've got a little chart that I've built. So we could go and do lots more different iterations, but you get the idea. And the nice thing is, like, I've created this notebook that's interactive exploratory analysis. I can share this with other people as well. So if I just go to the share button, I can look for Sam, because you know, he's going to want to see what I've done. There we go. And I can give him full access so he can basically edit this notebook and do whatever he wants. I could also, you know, I could search for Matej, our co-founder and CTO. I don't want him to screw up my code, though, so I'm just giving him read-only access. Don't trust that guy. And there we go. We've created a data product, which is a notebook. We've shared it with other people within our organization, and we're able to do that across boundaries of you know, cloud providers as well as cloud regions. So I think that's all we got except for the last slide, which is just a reminder that this is one of several data mesh talks that are out today. So if you have time, you know, either in real time at Summit or afterwards, you know, virtually, check out these other data mesh talks. One of our colleagues, Serge Smerton, is talking about how to automate your Delta Lake using you know, a Terraform provider that we've created. But we've also got a number of other partners and customers that are talking about their data mesh experience as well. So I think we've got time for questions. Yeah, thank you.
See hands go up, I'll bring the microphone.
Okay, we got some takers.
I see one coming over.
Oh, he's going to bring the mic over.
I saw a hand go up over here.
Oh yeah, over down here in the front.
Here you go.
Were you entitled to see the data across from AWS?
Were we entitled to see the data?
Yeah, so you shared
Yeah,
it.
so the fourth SQL statement is I'm giving a select privilege on that share
And that
for
was-
that recipient. So
Yeah.
unless I grant select privilege, he will not be able to see it.
That's brilliant. And that was done through UC?
Yes. So Unity Catalog is what manages the entitlements across both of these. So once Jason has consumed the share, then he becomes the owner of that catalog, which he will further tighten up. So for instance, he might grant access to select users for that catalog, and they will also be able to consume the share just like he did. So it is denied by default, which means nobody gets access out of the box. Even for an account administrator, they have to be given explicit privileges. Unless they are given that, they will not be able to see anything.
Yeah, so as the owner of the catalog, I can see it, and if I wanted to grant access to other people, it's just you know, grant access to this table to these users, and anybody that tries to access that will see through the lineage as well.
I have one more question. Okay. Did you also say that your customer had Synapse in it?
Yes.
Can you do the same entitlements for Synapse?
Sorry?
Can you do the same entitlements for Synapse?
No, because Unity Catalog is more inward-facing with Databricks. Synapse will have its own solution. So there is this concept of enterprise data catalog with Purview and many such tools where we will integrate with some of those tools. We are actually working with Microsoft closely to integrate with Purview as well, which means at some point in time, you would be able to have that singular cataloging / permissioning model, which can then enforce privileges across technologies. So that is the vision. But Unity Catalog is well and truly within the realm of Databricks.
Yeah, they basically access the Delta Lake through their APIs, and then they have to use their own cloud native security authorization to do that. So, and I think there was one gentleman behind that had a question as well.
Yeah, I think we have time for one last question.
Okay.
Yeah, there is one thing about data mesh in general which always strikes me as a bit curious, and that is the idea of, let's say, really having decentralized or federated data lakes. What's the point?
What's the point of having federated data lakes, or?
What's the point of having separate data lakes if you're one company and
So the question is, what's the point of having all these
what's
data
the
lakes?
added benefit? And because it's great that you can do data sharing, and I see the benefits of, let's say, working, for example, with joint ventures or external partners. Why would you do it if you're really one organization?
Yeah. Well, I think you're hitting on a point of like, why do you really need data mesh? It seems like it's a lot of extra things to deal with. And I think everybody has to decide if data mesh is right for them. If you're a really small organization, it's probably not right for you.
Yeah.
You have to be of a certain scale. So for one reason why people have multiple data lakes is because of data sovereignty. So if you're generating data in like Germany, you can't necessarily just share that with the rest of the world. You might be able to aggregate it into a anonymized way and then share that, but you can't just like have everybody from around the world connect to Germany's data. Another thing that I've seen with customers is we had a customer who was on AWS, and then they acquired another company that was on Azure, and they're not going to really migrate overnight, if it ever. So they had these two different teams that had two completely different domains, and they needed an ability to share that data as well. So.
All right, that puts us at time. Thank you.
I wouldn't
for attending.
Thank you so much.
Thank you.